Hello students, so we meet again in this geographical investigation series. So the topic that we'll be covering today is data gathering methods with regards to coastal GI, and the method that we are interested in looking at today will be beach profile and gradient analysis. All right, so just to recap what we looked at in the previous video and also the overview, basically these are the different techniques or methods that we have when we are doing coastal GI. And the method that we'll be looking at today will be beach profile and gradient analysis, which is used to actually track or measure the changes in beach slope or gradient in a coastal area. All right, so with regards to data collection methods, what we'll be covering in this video and all the other subsequent videos which talk about the different methods will be these three questions. So when do I use this method, which is to inform you of what kind of data am I looking for when I'm actually using this method. And the second question will be, how can I carry it out? So how can I do this method? Or what are the steps that I need to do in order to gather data using this method? And then the third question that we're interested in is, what do I need to consider when carrying out this method? So we all know that methods have certain steps that we have to do. However, there are some things that we need to remember when we're doing the methods to make sure that our gathering of data remains accurate throughout the data gathering process. All right, so the method that we'll be looking at is beach profile and gradient analysis. So this method basically involves the clinometer and ranging pole. All right, so tackling the first question, which is when do I use this method? Basically, you use this method when you are trying to study how the beach profile changes across space. For example, as a result of human intervention. So let's say humans have put in place certain hard engineering measures, and because this has disrupted certain transport processes, it results in the beach profile changing. So when you're trying to find out how the beach profile has been affected, you will actually use this method. Also, you can also use this method when you are trying to find the relationships between beach gradient and sediment size. So the closer you are to the foreshore, for example, the larger the sediment size. So when you're trying to also analyze, for example, what is at the different areas of the beach profile, you can actually do this. It actually allows you to track the different parts of the beach profile. However, the first point that I mentioned here is the more common usage of this method. All right, so tackling the next question, it is how can I carry it out? So in order for you to be able to do this method, there are some things that you will need. Basically, you need 3 people, and it would be good if 2 of the people who would be handling the ranging pole are around the same height. So 3 people. Next, you need a measuring tape, and then you need 2 ranging poles. I do hope that all of you are familiar with what a ranging pole is. And then you need a clinometer, which is this device over here. You can actually make a clinometer using straws, using a piece of straw, protractor, a piece of string, and a weight. However, all of you should actually have access to a clinometer, which will be given out to you some point during the field work. And lastly, you need a recording sheet. A recording sheet is basically a sheet which you have, which allows you to keep track of the data that you have gathered when you are doing this method. All right, so how do I carry out this method? So step 1, what you need to do is basically identify the line of transect on the beach that you are interested in studying. Okay, so after you have identified the line of transect, you actually have to also think about the sampling method that you want to use. So over here I have a diagram just to demonstrate to you. Basically what we have here is a top view of the coast or the beach. A line of transect is basically a straight line across the beach which is perpendicular to the shoreline. Basically it is 90 degrees to the sea. So it is a straight line that cuts across the beach, and that is known as the line of transact. So you want to identify this line that you're interested in studying first before you can do the other steps. Alright, so depending on your beach profile, like I've mentioned just now, we're going to talk about sampling methods now. So depending on your beach profile, the method in which you select or the method that you use with regards to your sampling will differ. So over here you see the method in which you select will actually influence the distance between the two poles, the two ranging poles. Well, I have a diagram to demonstrate this. Okay, so basically there are two types of beaches that you will encounter. The first one is beaches with a constant gradient. This means that the gradient does not really change drastically across the line of transact. So basically a beach with constant gradient will look something like this. So you see that there are no major changes. You'll see that there's no major changes in gradient over here across the line of transact. So for this type of beaches with constant gradient, what you can actually do is that you can actually do systematic sampling. So systematic sampling is basically the distance between the two poles at any one time would be constant throughout the line of transact. So for example, one person is standing at A, one person is standing at B, and there's 2 meters between you. Then when you go to the next points, it will be 2 meters, 2 meters, 2 meters. So it's very systematic. So the distance between the two poles will be consistent throughout. Alright, so for the next beach, which is beaches with observed significant changes in gradient, this type of beach is beaches that have significant rises and drops in the slope. So unlike the first beach diagram that I showed you here, which is like very straight, very consistent in terms of gradient, beaches with observed significant changes in gradient will look something like this. So there is a low and then sudden rise, low, sudden rise, and some beaches even have drops. So when you have beaches with clear differences in slope, what you want to actually do is stratified sampling. It is no longer advisable for you to use systematic sampling because you might miss some variations in the slope. So for example, let's say I put an interval of 5 meters, I may actually miss this slope here, and I would just end up with inaccurate reading of the slope. So for beaches as such, what you want to do is you want to do stratified sampling. So stratified sampling is basically you are choosing based on a special characteristic. So in this instance, the special characteristic will be the change in slope. So as you can see here, point A to point B, the slope is rather similar. So therefore, the rise is rather similar. That's why we group it as one, for example, one area of study. And then B and C, you see a sudden rise in the gradient here, and therefore we group it as another area of study. And then over here, subsequently, the same point applies. So what you need to know is that firstly, when you go down to the coastal area, you need to be sure of what kind of beach you're dealing with. Does the beach actually have a constant gradient, or are there very clear differences in slope? This is very important because it will influence the distance which is between the two ranging poles, which we will be covering later. Alright, so you need to remember this when you go out in the field, because as I've mentioned earlier, when you choose an incorrect sampling method, you may actually miss variations within the slope, which is very, very important when you're trying to track down the changes in gradient or the beach profile in general. Alright, so now that you have identified the line of transact, and now that you kind of know the sampling methods that you should use, the next step will actually be positioning of the rods, okay, the ranging rods. Before I explain to you the positioning process, I need all of you to understand that before you begin, you need to ensure that the ranging rods are of the same height. Okay, so over here I have a diagram. One is showing two rods that are basically at of the same height, which means that they are aligned. Meanwhile, the other one, you see the one on the left being longer as compared to the right. So this one is not aligned. So how can you actually align these rods? Okay, a tip that I can give you is that you do not align it based on the black portion over here. What you do is you look at the color indicators and align it from there. The reason why we do not align it to the black portion here is because these rods are actually subjected to wear and tear, and as such the some of the parts here may actually have been eroded or weathered away as a result of rigorous use. So you want to use these color markings in order to check that they are of equal height. Okay, so firstly, after you've identified the line of transact and your sampling method in step 1, what you need to do is person A, which is one person from your group, will stand at the start of the line of transact. So basically where you want to start measuring. Okay, so this will be point A. Remember, do not go into the water. You're just trying to track the beach profile. Okay, so person A will actually start standing where you want to start measuring, and that will be known as point A or position A. Remember to hold the ranging pole upright. It cannot be slanted because this will result in inaccurate reading. Alright, so then in step 3, after person A has taken his position, person C, which is not in the picture, will actually use the measuring tape and measure 2 meters, or the distance that you have identified as an interval. So as you can see here, just to make it clear, this is a beach with constant gradient, therefore I'll be using systematic sampling. So the distance will be the same throughout. Okay, so after measuring 2 meters, and then person B will take the position 2 meters away from person A. So basically this will be point B. Alright, so remember, person A take position, person C measure the identified distance, and then person B will stand at the position identified by person C. Okay, so you have basically this is all there is to positioning the ranging rods. Next up we have measuring the gradient. So now we have already put the rods in place. What we want to do is we want to measure the gradient of the slope, right? Okay, so person A will align the clinometer to the top of the ranging pole and look through it. So you see here, you have the clinometer aligned to the top of the ranging pole, and person A is looking through it. So just to give you a closer snapshot of a clinometer and how it works, basically this is what a clinometer looks like. When you tilt the clinometer, the string and the weight will actually be tilted, and then you can make the reading from the protractor that is on the clinometer. So this is a demonstration. So as you can see, I'm just going to rewind that again. As I tilt the clinometer up, we see the string and weight actually moving back. And then based on this, you can make the reading. This will basically be your angle of elevation or your gradient of the slope. Alright, so then after the person A has aligned the clinometer to the top of the ranging pole and looked through it, what person A should actually do is tilt up the clinometer till he can see the top of the ranging rod of person B. So remember, you guys have aligned the ranging rods, right? So then he will tilt up the clinometer and look through the straw to make sure that he can see the top of the ranging rod here. Okay, so if you think that this is too small for you, usually when you look through the straw, an easy way to identify is if you can see the eye level of person B. Basically through the straw, make sure you can see the eye level of person B. And then what you need to do is that once person A can see the top of person B ranging pole, usually the point where you can see person B's head, person C will look at the clinometer from the side. Okay, and then you will read and record the angle that is on the clinometer. So as you can see me pointing here with my mouse, person C, just take a look at the reading over here, and then make sure you record this on your recording sheet. Alright, so we see that after you have done this, congratulations, you have completed one section of the beach. Now, what you want to do is repeat steps 2 to 6 for the rest of the beach across the line of transect. Basically, until the whole line of transect has been totally covered and you have gotten your readings. That's when you conclude the conclude this method. You have gotten the profile. Okay, so now I guess some of you are wondering, now that I have all these numbers, now that I have all these angles, how do I actually get the profile? How do I imagine what the beach is like? So that is a very good question. Basically, let me just explain to you how it looks like mathematically, okay? So, as you can see, when I tilt up my clinometer, I am raising it up to an angle, right? It's similar to this right angle triangle over here. Basically, what happens is that if I shift this triangle up, you see that I am capturing this angle of slope. Alright, so when I made one measurement, I move on, I make another measurement. What I'm doing is that I'm capturing the gradient or the angle between point B to point C, point A to point B, and then I've gotten the angles in terms of numbers, right? Then after I have recorded all this down in my recording sheet, what I need to do when I go back to school or when I am actually at the beach itself, I can actually use a graph paper and plot your findings. Okay, so you see from position A to position B, the beach gradient is 30 degrees. So I map it out. Then I will, from position B over here to position C, I map out 40, the angle of 40 degrees, and then I connect the line. So by connecting all the lines A, B, B, C, you'll actually get the general profile of the beach. So based on this graph over here, gradient is denoted on the y-axis and distance from the shoreline is denoted on the x-axis. So these are the things that you need to look out for when you are mapping your beach profile. Okay, so if you're confused about how to carry out this method, just watch this video or the previous section a couple of times, because I understand that mathematically it may be hard to understand how does capturing the angle translate to me getting the gradient of the slope. Well, just slow down the video, pause, rewind, and make sure you understand before moving on. Alright. So congratulations, now you should know how to conduct beach profile and gradient analysis to study how the beach profile differs across space. So for example, I can compare between one line of transect and another line of transect and then compare how the gradient differs between these two parts of the beach. And then I can try to come up with a reason why this happens. So remember, it's okay if you need some time to understand the whole process, just rewind and make sure you understand before moving on. I'm sure all of you will be able to understand this if you put your mind to it. Alright, so now lastly for this method, what do I need to consider when carrying out this method? There are 4 things for you to consider and to remember when you're doing this method. Firstly, you need to hold the ranging poles upright and make sure they're of the same height. Because when they are not upright, you will get an inaccurate angle, and then this will affect the whole beach profile, and then you have to redo. Secondly, do not bury the poles in the sand, as it may affect the accuracy of the reading. Remember, you have aligned it when you first begin. So when you bury the pole, let's say you bury the red part of the pole, then this alignment is just totally off. And again, inaccurate readings have to redo. Thirdly, read the clinometer at eye level to prevent parallax error. When you read it from the top or when you read it from the bottom and not at eye level, what you may actually do is you may over or underestimate the angle, and this also results in inaccurate reading. Remember, we want accurate reading, we want good data. And then lastly, the best time to measure beach gradient is actually during low tide, because you can measure the different parts of the beach that are not submerged by the high tide. So when you are selecting a time to go and actually do your GI, be aware of the high tide and low tide so that you are able to not waste your trip over there. Alright, So we are done with this section here on beach profile and gradient analysis using the clinometer and ranging pole. The next one, the next method that we'll be going through is sediment analysis. Remember, do not be shy to actually just rewatch this video. Make sure you understand everything before you move on. Remember, our goal here is to understand and not to simply memorize the different methods. All right. So thank you for tuning in, and I'll see you in the next one.